or do you want to start?
We should start now at 6. The recording started, I think.
Yeah, the
Should we
recording
start
started.
but should we start in like 5 minutes? So more, I think more people.
2 more minutes, maybe.
Yeah, let's just wait a few more minutes.
Yeah, just a few more minutes to give time for everyone to join, and we'll start.
I'm gonna get people. Hey, I see you.
Yeah, 5 more people. That's great.
Thank you, Anik. Melissa, I think we should start now. The recording's probably gone on for a minute already.
All right. All right, everyone. Thank you for coming to our machine learning and TensorFlow workshop. I know it's a Friday evening and lockdown is over, so I really appreciate to see everyone here today. Thank you so much for coming. Before we start, I would be delighted to present our team, which consists of 5 people. I am Melissa Bogdan, and I will introduce you to the concepts of machine learning. And later on, I will walk you through the steps on how to build a machine learning model. And now I will pass on to my colleagues, and they will introduce themselves to you.
Hi guys, my name is Chris Musa, and I'll be talking to you about how machine learning works and about deep learning.
Hi guys, my name is Rayan, and I will introduce you guys to TensorFlow.
Hi guys, my name is Mohammad Saad Patel, and I'll be demonstrating computer AI versus player tic-tac-toe using Minimax on Python.
Hi guys, my name is Shuri Shadaf, and I'll be walking you through some code using TensorFlow and Keras to create a neural network which will hopefully classify some images of clothing.
All right, that's wonderful. So what do you guys know so far about machine learning or TensorFlow? I didn't know anything about TensorFlow just a few months ago. So I was very amazed about what I can do with TensorFlow. I knew a little bit about machine learning, but I was completely new to TensorFlow. So do you guys know anything about TensorFlow? Nothing.
Awesome.
We're gonna learn a lot today.
Yeah.
Come on.
We'll try our best to deliver the information to you guys. And if you have any questions, please keep them for now. And at the end of our workshop, we'll be more than happy to hear them. Or you can, if you want, you can write them down so we won't forget. Either way works. Okay, let's see. Just a few conspiracy theories about machine learning. Same. I love them. Automation, okay. Embedding autonomous intelligence into machine. Whoa, yes, exactly. That's good. All right, I'm super happy to see you guys have a bit of knowledge about it. That's great.
Let's go.
All right. Before we talk in detail about machine learning, I want to emphasize on the difference between artificial intelligence and machine learning. So artificial intelligence is the bigger concept of programming more smart machines to behave like humans and think like them. And machine learning is just a subset or an application of artificial intelligence that can learn from a set of data without being explicitly told how to do it. So artificial intelligence has many fields, so machine learning is just one of them. So if you want to do, let's say, AI in the future, then it's good to be informed about your options, basically. All right, so how is machine learning different than normal programming. And when I say normal programming, I'm referring into traditional programming. And when you first start to program ever, you're learning the traditional way, where you have a set of data and some rules. And when you run the program, it should give you as output answers. But machine learning is a bit different. In what way? Well, we already have the sets of data and the answers to this data. Let's say the data are some questions and you already have like the answers. And when you run the program, the output should be some rules. So in traditional programming, let's say you have, let's say, some mathematical expressions, and you have the rules, like the steps on how to solve it. And the program will just give you the answers. But machine learning is different. You have the answers, it's like the result of these mathematical expressions, and the data, of course, are like mathematical expressions. And like the algorithm is trying to find patterns, some way, some connections between them, and come up with some rules. It's very important to have lots of sets of data, different ones, so we could come up with different rules, so the predictions and the accuracy of them would be better. All right, right now, let me share my screen again. I will show you a really cool and free application of machine learning. So just 1 second, please.
Let's go.
All right, can you guys see my screen? Just checking.
Yeah, we can.
Yeah, we can.
Okay, so this application, so like this web application, is called Quick Draw. It's free, everyone can try it. And it's basically a game that uses a neural network to learn and recognize your drawing. And we're going to try and see how it works. Basically, right now we're training the machine learning model. We're giving a lot of data as input. And based on like my drawings, it's trying to make better predictions in the future for the next players. I'm not very good at drawing, so if I fail to do the task, please be kind to me.
Nah, you got this, Melissa.
A paint can. And I have to draw this in less than 20 seconds.
This one's easy, Melissa.
Easy.
Yeah, it has
Nah.
easy. Come on.
If you don't
Okay.
get this, Melissa, I don't know. Just leave.
Yay!
Yay.
Necklace. Oh, that's gonna be interesting. Okay, let's see. These are not balloons, but
Go right.
Yay.
Yo, come on.
the Great Wall of China. Let's
Just
see.
go Humpty Dumpty.
I don't know how it looks like though.
Humpty Dumpty.
Humpty Dumpty.
I don't know, it's a wall,
Make a wall,
right?
then draw an egg on top. Oh my, what is this?
And that's not a jail. That's jail.
Nah,
So-
this is poor.
I mean, these are the towers of the.
Oh no.
It was close. You tried.
I try. Well, it doesn't have to be perfect, right? So a basket. Oh, that's not easy. Let's see. Okay. I'm happy that the machine learning algorithm is smarter than me. Cooler.
I can't lie, I don't know how
Yeah, this one's easy.
Yeah.
Yeah, harder than
Same.
usual.
just draw,
Is it cooler like, I don't know. Give me some ideas, guys, how to draw this.
just
Draw.
draw. Yeah,
Not
fine.
sure.
That's good, Ajma. That's a good one.
Well, let's say that we draw something completely different and see how it gets. It doesn't always have to be perfect, right? So, I don't know.
A box with a handle. Draw that. Someone said.
What? Can you say that again?
A box with a handle.
A box with a handle.
Yeah.
Okay, let's say I can do that. Is that a box?
That's
With a
not.
handle? It's supposed to be like a box.
What kind of boxes do you draw?
That looks like a mug.
Don't judge me too much, please.
That looks like a mug.
It looks like a mug. Talking about mugs, stay tuned until the end.
A stove. I'm not exactly sure what it is.
Okay.
Stove.
Oh,
Yes.
It's where you cook.
yeah.
Yeah.
Oh, okay. Let's see. I don't know. Whatever I draw is gonna like, I don't know, try and draw.
Yeah.
Yeah.
There you go.
So 4 out of 6 were correct, which is very impressive for an online game, really. So I think that the machine learning algorithm is pretty cool, considering my my bad drawings. But thank you guys for helping me. I love the teamwork. All right, I will share my screen again. Give me 1 second. All right. And now I will pass on to my colleague Krismita, and she will talk more in detail about machine learning.
Hi guys. Now let's see how machine learning works. So machine learning works in 2 ways. One way it learns is through supervised learning, and the other way is unsupervised learning. So first, let's look at how supervised learning works. So as the name suggests, supervised learning is where the machine learns under supervision, or like it's like learning under a teacher. So you're teaching the machine how to do something. The way you do this is you feed the machine in with data that's already tagged with the correct answer. So as you can see in the slide, they're giving the machine pictures of cats, and they've also labeled that this is a cat, so the machine knows what this is. So the machine learns from this data, and then in the future, when it is given similar data, it's able to predict outcomes for those unforeseen data. So as you can see, in the future, when they give it different pictures of different animals, it's able to recognize which of these are pictures of cats and which of these aren't. So supervised machine learning helps you solve lots of real-world computational problems. Let's look at an example of how we can use machine learning in a different way. Can you go to the next slide, please? So here, let's look at how we can use machine learning to train, to predict commute time. So in order to do this, you need to give the machine a set of training data. So this data should include details such as weather condition, a time of the day, and holidays. These 3 conditions are known as the input data. You should also give it output data, like the time taken to travel home from work each day. So this input data and output data is known as your training set. And what your machine does is it learns based on this training set. It will look at correlations between this input and output data. For example, like us as humans know that if it rains, then it's going to take us longer to travel home. But the machine doesn't know it itself. So by looking at this data, it sees that every time it rains, it's taking you longer to come home. So it ascertains that when it rains, commute time is longer than usual. And it might also see that every time you leave work closer to 6 p.m., it also takes you longer to come home. Am I echoing?
No, that's all right.
Right.
Okay. All right. So from here, the machine is able to see that different times of the day also affect the time it takes you to come home. And supervised learning uses techniques such as classification and regression. Now let's look at how unsupervised learning works. So unsupervised learning is basically the opposite of supervised learning. This is where the machine learns on its own and discovers its own information. Unsupervised learning mainly deals with unlabeled data. And this type of learning can be useful for categorization. So let's see how we can understand unsupervised learning. So This type of learning is very similar to how a baby's brain works. It's weird, but it's very similar and easy to understand this way. So imagine there's a baby and she has a family dog which she plays with every day. She knows that this is a dog and plays with it. And say that a few weeks later, a family friend visits them with their dog. The baby doesn't know that this other creature is a dog. No one's told the baby that this is a dog. But then what the baby does is it realizes that this animal has 2 ears, walks on 4 legs, and has eyes which are similar to its own pet dog. So then the baby realizes that this is a dog. Similarly, unsupervised learning the machine learns
Hello?
Your mic's gone a bit weird.
Can you hear me now?
No, not really. It's kind of quiet.
How is it now?
I think it's better.
Okay, sorry. So, like this, unsupervised learning learns from the machine learns from experience rather than you telling the machine information. Let's now look at how classification, regression, and clustering works. So first, let's see how classification works. Can you go to the next slide? So classification is the process of categorizing a given set of data into classes. It can be performed on both structured or unstructured data. So a great example of classification is the quick draw game that Melissa showed us at the beginning. In that game, a large amount of data is used to teach this game how to recognize images. There, instead of the programmers creating rules, the model is trained with examples. For example, if you want to teach the game to recognize what a carrot is, rather than trying to define what a carrot is for the computer, what they do is they give lots of varying examples of drawings of carrots and show that they're all carrots. This approach results in more flexible understanding for the machine as well. Let's look at, now let's move on to regression. Regression is another supervised learning technique which helps you find correlation between variables and enables you to predict continuous output variables based on one or more factors. And so in regression, you plot a graph between the variables which best fits and given the data points. Using this plot, the machine learning model makes predictions about the data. This gives the model the ability to predict outputs for inputs it hasn't seen before. And regression is used for many applications such as electricity load forecasting and algorithmic trading. Now let's move on to clustering, which is used for unsupervised learning. Clustering is very similar to classification, except this is used for unsupervised learning. So what clustering does is it divides the population or data points into a number of groups that are very similar. So it's basically used to segregate groups with similar traits and assign them into different clusters. An example of how clustering is used in real life is, say a cell phone company wants to optimize the locations where they build cell phone towers. They can use machine learning to estimate the number of clusters of people relying on their towers. A phone can only talk to one tower at a time, so the team uses clustering algorithms to design the best placement of cell towers to optimize signal reception for groups or clusters of their customers. Now let's look at a brief introduction into deep learning. So deep learning is a subset of machine learning, and it works on the structure and function similarly to the human brain. The way that deep learning works can also be compared to the way a child's brain works. So
let's look at how a child learns a language. When a child is learning to speak, say the child points at an object and says that this is a car. The child's parent immediately provides it with feedback saying whether it's right or wrong. After enough feedback, the child eventually forms an internal mental model of how to label different objects in the world. Deep learning works just like that. It's trying to mimic the human brain. So in deep learning, we create a neural network of digital neurons arranged in layers, with each layer's neurons interconnected to the next layer's neuron. The first layer is the input layer. This layer picks up input signals and passes on to the next layer, which is the hidden layer. And finally, there's an output layer, which delivers the final results. This is how we provide training data, such as, so if you want to provide the machine with training data, such as objects, to the neural, sorry. So we provide the machine with training data, such as pictures of objects, to the neural network, and have it try to guess what each object is. Of course, at first, the guesses wouldn't be right, and it might be atrocious. But as we provide feedback, the neural network adjusts to how the neurons are connected until it produces accurate guesses. And a deep neural network is one that has more than one hidden layer. Now, Ryan will talk to you about TensorFlow.
Ryan, you're muted.
My bad. Sorry. Okay, hello everyone. So I'm gonna introduce you guys to TensorFlow. And so what is, have you guys heard of TensorFlow? I don't think, yes, that's good to know. All right, cool. So I'll just give you guys a brief introduction to TensorFlow. And so what is TensorFlow? TensorFlow is an open source library developed by Google primarily for deep learning applications. It also supports traditional machine learning. It is also developed originally for large numerical computations, such as when creating deep neural networks. So TensorFlow accepts data in the form of multi-dimensional arrays called tensors. And I'll explain this later in the next slide. And multi-dimensional arrays are very handy in handling large amounts of data. TensorFlow works on the basis of data flow graphs. These have nodes and edges. Nodes in the graph represents the instance of a mathematical operation, such as multiplication, addition, and so on. And the edges are tensors on which the operations are performed. I'll also demonstrate this later on. So as the execution mechanism is in the form of graphs, it is much easier to execute TensorFlow code in a distributed manner across a cluster of computers while using GPUs. Okay, next slide, please. All right, so what are tensors? Tensors are multi-dimensional array in which the data is stored. When we are doing deep learning, especially the training process, you will have large amounts of data, and the data is typically in a very complicated format. So it really helps when you use tensors, as is a very nice compact way of storing and handling data during computation. So the data is stored in tensors, then it is fed into the neural network, then you get the output from that. Next slide, please. All right, so there are some terms associated with tensors. One is the dimension and the other is the rank. So what is the dimension? Typically, the dimension is the number of elements in a way, so you can see on the right hand side a 5x4 dimension tensor, and then you can have a multi-dimension where you can see at the bottom, which is a 3x3x3 tensor. Next slide, please. Okay, so these are called tensor ranks. So these are traditionally what we would have thought of as dimensions. That is actually in this case called ranks. It will be easier to see when we explain when we see examples of it. So a tensor's rank is supposed to be 0 when there is only one element. So in the first case, we can see on the top left, it will just be 200, which we call a scalar. Then on the right, we can see a tensor rank of 1, which has one-dimensional array. This is a vector, essentially, a row of elements. And so that has a rank of 1. The next one on the bottom right is a 2-dimensional array, which is like a matrix. So the rank is 2. And then the last one we can see is a rank of 3, and then it can have more ranks as well, as tensors are multi-dimensional arrays. So you can have rank 5, rank 6, and so on. So those are the terminologies, dimensions and ranks that we've just gone through. And these just make sure, this is just to make sure that we are speaking the same language. So whenever we talk about the rank of a tensor, you understand what is meant by that. Next slide, please. So now, addition to tensors in which the data is actually stored, once we have the data, computation needs to be done that is in the form of graphs. So what we do in TensorFlow is not like traditional programming where you just write a bunch of lines and then everything gets executed in sequence. Here we prepare graphs with various nodes, and then these are executed in the form of a session, and they use the data from these tensors. This is slightly a new concept for a lot of you. So maybe it will be a little difficult to understand. When my colleague goes through the code, it will be easier. Yeah. So the first step is preparing the graph. And when we are preparing it, none of the code is actually getting executed. You write the code to prepare the graph, and then you execute the graph by creating a session. And that's the way TensorFlow program works. So each of these computation is represented as what is known as a data flow graph. So the graph gets executed and it processes all the data that we are feeding. All the external data will be fed in the form of what is known as placeholders, and then you have variables and constants. Once we have the graph, then the execution can be enabled either on a regular CPU or GPU, and also in a distributed manner so that the processing becomes much faster. Next, please. So this is how the TensorFlow program looks. So you need to build a computational graph and then execute that graph. So the first step is to write the code for preparing the graph, and then you create what is called a session, and in that session you execute the graph. Next slide, please. All right, so why use TensorFlow and why not use any other libraries? So TensorFlow offers a high-level API. Therefore, we don't need to go deep into preparing a neural network or to configure or program a neuron. These are done by the library itself. So all you need to do is use the API and essentially call that API and pass the data through it. This is much easier than actually going down and writing everything by yourself. TensorFlow supports multiple languages, though Python is by far the most popular language. And deep learning applications are very compute intensive, especially the training process needs a lot of computation and takes very long as the data size is large, and there are many mathematical calculations and matrix multiplication and so on and so forth. So for that, if you perform these activities on normal CPU, typically it will take much longer, but GPUs are very good at handling these kind of calculations. So now they are being used for developing deep learning applications. And TensorFlow supports CPUs as well as GPUs, so I think that's one of the major advantages using TensorFlow. I will now pass it to Melissa, and she will go through how to build an AI model.
Thank you very much. All right, now that we talked about TensorFlow and all the incredible things that we can do with it, we're ready to talk about what an actual machine learning model is. So let's refresh our memories a bit. So when we want to build a machine learning algorithm, we need a set of data, answers, and the output would always be rules. This is called the training phase. We give millions of sets of data if necessary for a good algorithm, and we come up with as many rules as we can. And the next step would be the inference phase, where we feed the model with data, new data that it has never seen before, and the output should be some predictions. An example would be, the prediction is that 80%, there's an 80% chance that the pictures in the data set have cats in it, or something like that, and 20% chance that there's other animal. So something like this, we need to give a lot of new data to test it and see how accurate the predictions are. A very good old example of a game that, let's say, uses machine learning online is the rock, paper, scissors. So this is a set of data, and in this case has just 9 pictures in it of different people or different races and different kinds of hands trying to do the rock or paper or scissors science. And as you can see, some people use 2 fingers for that, or like 3, or they fold their hand weird, or there are many ways of showing it, right? So we need as many pictures as possible, as many data sets to train our model to understand that, oh, the first picture on the first row is the scissor sign. And the second one is also a scissor sign, even though usually they're like you show just 2 fingers, and so on. So instead of coding and compiling the model, we just call it training. So when I say that we're going to train the model, it means that we're building it and we're compiling it, both of them together. But how does how does a model look like, or how do we implement it? So there are a few steps to do so. The first one is to explore the data, and the data can be in different formats. It can be images, number, mathematical expressions, and we need to make sure that our data is pre-processed, as in we want to make sure that it's in the correct format, otherwise we can't work with it, right? And the third step would be to build the neural network. And to do that, we need to set up the layers. My colleagues have walked you through the steps already. And the next one would be to compile the model. And in order to do that, we need to measure how accurate the model is during the training. And this is called the loss function. Then we have another function called optimizer, which updates the model based on the data it has seen before. And it sees right now when we run the model. So it's updating real time. And the third function would be metrics, which checks the accuracy of the model. And this is just an example of the code of how to compile the model, basically with the 3 functions that I mentioned before. And don't worry if it doesn't make a lot of sense now. My colleagues will walk you through properly how to code it. So don't worry about it. And the next step after building our model is to train it, and it also has a few steps of its own. So I try to make like a pyramid of what you need to do. So you need to look from the bottom to the top. So first we need to feed the data into the model, and usually it's in form of arrays, like a list of all the data in a specific order. The next step would be the model, that the model learns how to associate the new data with labels. So it's labeling it, such as, oh, this is a picture of a cat, this is a picture of a dog, and it's putting them in different categories. Then we ask the model to make the predictions about the test sets that we're giving it. And for the last would be to verify if the predictions match the labels, which is very important. We need good accuracy, otherwise it means that something is going wrong with our model. And when we're evaluating the accuracy, the worst case would be overfitting. So here are just 3 representations of the output of a model and 3 possible outputs. The overfitting one is the worst because the line that, like the blue line here, that it's like connecting all of the outputs basically. It's all over the place. The output is all over the place, and it's not forming, let's say, a straight line or like a curve, like a mathematical expression, basically. And these outputs are from the training phase and the testing phase. And if there are too many outputs above the line, it means that something is wrong, the same thing as when there are too many underneath it. Oh, sorry. And the best way to do it is to have like almost an equal number of outputs above and below the line. Okay, so what can we do actually with TensorFlow, like some real life examples? Well, we can predict extreme weather with it, or we can diagnose diabetes retinopathy with it. So you either test or build your model in TensorFlow, or actually it's better, you can do both of them. So it's a free platform for everyone, and I think is pretty cool. And now I will pass on to Saad, and he will show you some really cool applications. I will stop sharing my screen now so he could do that.
Can you see mine?
Yeah, we can see.
Yeah.
Hello, so I will be demonstrating computer AI versus played tic-tac-toe using Minimax on Python. Is it echoing?
Yeah, it is.
Why is echoing? Okay. Minimax is a backtracking algorithm that is used in decision making and game theory to find the optimal move for a player, assuming that the opponent also plays optimally. It is widely used in two-player turn-based games such as tic-tac-toe, backgammon, and chess. In this course, we'll be using a grid system to represent our board. To do this in Python, we will create a list called board that will start off with 10 empty values. The reason we have 10 empty values rather than 9 is because when we get input from the user, they can type numbers 1 till 9, not 0 till 8. So to make it easier, we are going to make the first value of a list an empty string. So if you can look over here, this following code can simply just gives us a range from 1 till 9. And then moving on, the function def insert letter is going to take two parameters, letter and position. It is simply going to insert the given letter at the given position. And now moving on, the function space is free. The function below will simply tell us if the given space is free, meaning it does not already get contain a letter. It has one parameter position integer from 1 till 9. The function will return a true or false value. And so now is a general graphics of the game. And now if you just see over here, the function def print board takes the board as a parameter and will display to the console. And the board is a list of 10 strings representing the board. So now here you can see just like the grid system in tic-tac-toe from 1 till 9. So this is basically the graphical interface of the system. And
So
You
you're
guys hear me?
muted.
Yeah, Saad, you're muted.
can you hear me now?
Yeah.
Yeah.
You're good now.
Automatically move that now. That's strange.
Oh,
So the function will tell us if the given letter has one based on the current board. It has two parameters, bo, which is short for board, and le, which is short for letter. The letter must be an X or an O. So we will simply check each possible winning line on the board and see if it is populated by the given letter. So given a board and a player's letter, this function returns true if the player has one and false if he hasn't. And we use board instead of board and le instead of letter, so we have to be concise and to save some space. So if you just look over here, the def is when a function. The first one is simply across the top because it's 7, 8, and 9, and across the middle, across the bottom, down the left side, down the middle, down the right side, diagonal and diagonal. This is basically all the conditions because you can win tic-tac-toe through many different ways. And now the function, the play move, which will just like, so in this function def play move, we will be asking the user to input a move and validate it. If the move is valid, you will add the letter to the board. Otherwise, you will continue to ask the user for input. So if you can just see how the function is, so this one basically makes sure we type in number 1 till 9, and the space is free. Check if the move we choose is valid. No other letter is there already. And now for the main part of code, now time for the AI. This function will be responsible for making the computers move. It will examine the board and determine which move is the best to make. The algorithm will follow is listed below. If the current step cannot be completed, proceed to the next. If there's a winning move, take it. If the player has a possible winning move on the next turn, move into the position. Take any of the corners. If more than one is available, randomly decide. Take the center position. Take one of the edges. If more than one is available, randomly decide. If no move is possible, the game is a tie. So here you can see this basically shows create a list of possible moves, and here is basically check for possible winning move to take or block opponent's winning move. So when we are winning, the computer will know when we are winning. I will simply cancel our move. So basically the game goes on. And this one is try to take one of the corners, and this one is try to take the center, and this one is the edge. And this one is basically randomly decide on a move to take given stop possible position. So when the game starts or in the initial stage, it can just choose any position. And this function, the def is board full, will take board as a parameter and will simply return true if the board is full and false if it is not. And since you always have one blank element in board, we must use greater than 1. And now how we'll start the game. So the function def main is what we will call to start the game. It will be calling all the different functions in our program and dictate for the program. So this is basically all the statements that we see on the board. For example, sorry, O's won this time, tie game, or computer placed an own position move. So basically to control the flow of the game. So now starting the game. Now that all our functions completed, let's start the game. So if we just want to run the game once all, we will just have to run the code from the main. However, in our case, we want the game to keep running until the user doesn't want to play anymore. So we will create a small while loop in the main line. So it just continues playing. And if you can hear, you can see it. I'll just now run the code. So if I just press yes, now basically it will return to tic-tac-toe. So please select a position to place in X. I will just press, for example, 7. Now the computer has placed in the third row, in the third column. So I will just press 1 now. Now you can see the computer knows I was winning, so it just places 0 over here. And now
That's sick.
Yeah, so now I can just put over here. You just put 6 over here.
You can win, bro. I believe in you.
I won once, I don't know. So now I'll just like, so the game will basically tie now. I'll just press 8 over. Wait. Just press 8 over here. And so now the game is basically a tie. And yeah, so it's a tie game. And now if, for example, yeah, so that is one. So I will now pass on to Shoresh and he will give you further example of machine learning and TensorFlow.
Amazing. Thank you, Saad.
That's great.
Okay, hi everyone. I'm just going to share my screen. Give me 1 second. Okay, let me know when you can all see this code.
Yeah, we can see it.
Yeah,
We can see it.
Okay, guys, I hope you're all in the job. I hope you all have a better insight in what machine learning and TensorFlow is. And for anyone that's been confused about all this code and everything being thrown at them, I'm going to be taking you through a more simple code and how to create a neural network in a more simple way. So I've written this code, Python code, on Google Colab. Google Colab is a program that makes it a lot easier to write your own code. There's no installation or anything required. You can just jump on it and write it. So let's get started. So we have imported TensorFlow and also Keras. And just one thing before I start, all of this green is my explanation file, so don't worry too much about that. Anything in the dark colored writing is what I'm looking at. So we import TensorFlow and Keras. Keras is a deep learning API. It allows you to define and train your own neural network models in just a few lines of code. So it makes it a lot easier for us, since we're not defining and writing our own tensors. We also import NumPy, which allows us to carry out mathematical operations on our arrays. And we also import matplotlib, which allows us to graph our results at the end, which you'll see. So first we import our data, which is provided by Google. And all this code that I'm going through now is also provided by Google. I've just explained it and written the explanation file and edited it a bit. So we have imported first we're going to import our Fashionments dataset. So I first should explain actually, what we're trying to do here is classify images of clothing. So we have a dataset of images of clothing, and we're going to run it through the network, and the network will make a decision or based on accuracy and loss function to see which one it thinks it is. So it would have attached labels to the images, and we can check if it's right. And this works by running the data through the neural network, which you'll see. So if we just look at this, we're importing our data with Keras, and this essentially allows us to split our data into training and testing images. So I want to throw this question to you guys. Why do you think we split our data into training and testing? So we have two data sets essentially. Why don't we run our full data set through the neural network instead of splitting it into training data and testing data and running them separately through it? Can anyone answer that? Yeah, sure. I can share this code. Can I share it after? Because I'm not sure.
Yeah, sure. We'll share afterwards.
Okay, I'm going to explain the question one more time because it could be a bit confusing. So we're running our data through the neural network. However, we split it into training and testing. So why do we split it into training and testing instead of just running the full data set we have through the neural network and then testing it on the same data set? So if you feed all the data during the training, then it will always have 100% accuracy. Yeah, that's a good explanation. Maybe to ensure that the program does not memorize the answer. Yeah, so essentially that those two answers are great. So the reason why we split it into training and testing is so that the data doesn't so that the model doesn't see all the data, because then we won't know whether the model has memorized the data or it's actually learning from it, analyzing and learning from it. So what we do is we split it into training and testing, and we run around 90% of the data as training images, and around 80% of data as training images, and around 20% of the data as testing images. So we can just carry on from here. So here we have just classified the class names and have set it to an index. So when we run the data through the neural network, it gives an output from 1 to 9, and that's assigned to each one of these class names. That's all this code is. And if we move further down, so because we have stored these images in NumPy from the start, we can simply just carry out this mathematical operation of dividing the training and testing images by 255, which is the maximum value of the pixels. And this gives us the range between 0 to 1, which we need. If we move on. So you've seen my colleagues talk about neural network and me talk about neural network. And this is essentially it. So we have our input layer, our dense layer, which is the hidden layer, and our output layer, which is the third layer here. And if I just go through this quickly. So each shape has an array of 28 by 28. We cannot pass a 28 by 28 array through one single neuron. So we need to flatten it by multiplying it out. So we have 784 pixels. And now we can pass it through our neural network. So that's why we have a flattened layer. Our second layer is a hidden layer. So you may ask, why don't we just have an input layer and an output layer to make this process go a lot faster? But a hidden layer gives us more biases and weights. And essentially, these biases and weights can make the neural network pick up on more patterns, which should increase the accuracy of the neural network. So with more weights and biases, it has a more chance of getting the label to the image correct. And finally, it's our output layer. So this lights up. So in the output layer, there's 1 to 9 neurons, and each one is connected to a certain image. So if we look back here, we have t-shirts, trousers, dresses, etc. So each neuron is connected to that, and each one lights up a certain amount. And when it lights up, it gives you a percentage that it thinks it is. And essentially, softmax adds that percentage to just add up to 1. So it has a 0 to 1 value, and some could be 0.1. And some could be 0.9. And that's essentially what it does. It just rounds it all up to 1. We have our optimizer next. So optimizer, essentially, what it does is what it says in the tin. It optimizes our neural network. So when we run our data through the neural network, we're of course not going to run it once. We're going to run it many times so the model learns from the mistakes it'll be making. So every time we run it, the optimizer will make adjustments to the weights to make the neural network more accurate each time. And we also have our loss function, which my colleague Melissa talked about, which gives us an accuracy and also a loss function. So if you scroll along. Okay, so we have to run our training images through the model first. So this is what we've written here. This line of code runs the training images, which I said was 80% of the data that we have. We run that through, and we run it 18 times. So epoch sets how many times we run it through our network. So we're running it 18 times. You can increase the value, you can decrease the value, depending on what the accuracy is. So I've set it for 18 times because it gives you a good accuracy value. And so what this does is it runs all the data we have through the network in different orders. So the network doesn't memorize it. So it runs it in different orders, 80% of the data, and then it learns from that. And once it learns from that, we can put in the testing data, which was 20% that I talked about. So from the testing data, what it does is it's learned, we've trained the neural network, and now we're testing the neural network to see whether it has learned anything from training it. So here we're just putting in the testing data through the neural network, and we'll see the output. So I've already run this, and okay, so I should talk about this. Is just to graph our final results, and you can see at the bottom. So if I scroll down, so if you're paying attention, you would know what this is, epoch. So like I said, we run it through the neural network, all the data, different orders, 18 times, and that's what we've done here. So as you can see, we start with 0.8 accuracy value, and while running it, the accuracy has increased to 0.89, and it also gives us a loss function of 1.58. So you can see that that by running it again and again and again, the optimizer is working, and it's optimizing the neural network, and it's making it more accurate. So here is our results. So ankle boot, so it's got most of it correct. You can see that this is a code and it's guessed code, and you can see that how much it thinks it is, which is pretty confident. Most of it is 23% confident that it's the image that it says it is. However, you can see here that we've got this one wrong. So what the neural network predicted was it being a sandal. However, it's clearly a sneaker. But you can see why it made this mistake. So I'll throw this question to you guys again. How do you think we could improve the neural network to not make this mistake again? So you could do anything. So give me some examples of what you could do to improve the neural network to fix this mistake that it's made. Yeah, basically more data. And we just, I was hoping someone else answered. Okay, so we have, so you're correct. More data will mean that neural network has learned, will learn what a sandal and sneaker will look like. More basically, it can maybe pick up on more patterns and get this one right. So now I'm going to take you to a more complex kind of code. I'm not going to walk you through this too much, but this code isn't mine. This is by Misbah404 on GitHub. So I found this code, I just tweaked it a bit. So what this code is a face mask recognition. So if you think about like some supermarkets, like they have the cameras and you can see your own face, and it has like a green box around your face, and it can spot what a face looks like. And this is essentially machine learning. And this face mask recognition one could be implemented in like the TFL, where it is mandatory to wear a face mask. So if we, so I've tweaked this code a bit just to make it a more personal touch, so you can see what I mean. So I've run images of my own team through this network, a neural network, and it's given me an output, so you can see it. So we have Saad. Saad is not wearing a mask, and it's 99.99% correct. So this one's interesting. So my friend Ryan, he's wearing a mask, but I don't think the neural network can detect that this is a face. Maybe it's because of the angle the photo is taken at, or it's because the color. So the mask is essentially the same color as his jumper, and it probably can't detect what's going on. It's more likely to be that it can't detect a face, to be honest. And if we scroll down, we can see Chrismy. She's wearing a mask, and you can see it's very accurate. And finally, we have Melissa, which is not wearing a mask. And one more thing I want to go is, I know you guys probably want to stop talking, but final thing, I've basically run a recording through this neural network to see whether it can tell if someone's wearing a mask or not in a moving image. So if we just have a look at that. So this is me. Okay. Tell me if you guys can see it. Can you guys see it?
Yeah, great.
Okay, so I'm just going to go through it slowly.
That's big.
Okay. Thank you guys for listening. I hope you enjoyed. Yeah, I'll pass it on to Ryan now to do your favorite part.
Have a drum roll, please.
No.
Let me guys share my screen first, because Ryan, you have to do the honors and present the prizes first. So let's get everyone excited.
Oh yeah. Share the screen.
All right, give me 1 second.
Come on. Get the screen up. Yes, please.
Can you see it?
Oh yeah. All right, guys. So we have 3 prizes, yeah? Not 1, not 2, 3. All right, cool. So 3rd place, we get a mouse pad. And this mouse pad is premium quality. Like, it's very thick and it's very good for the mouse. All right, 2nd place, we have a self-stirring mug. Like everything's becoming automated these days, yes? There's no more stirring, it's self-stirring. So it's sick, isn't it? And then 1st place, we have a wireless earphones. And this is honestly best audio mic quality. You guys have to win that 1st place prize. I want to see you guys there on the top. But all right, let's go to the quiz.
Okay, okay, can you share your screen now, Ryan, and share the code for everyone?
Yep. I'll share my screen.
Amazing.
Good luck, everyone.
Yeah, good luck.
Good luck, guys.
We'll need it, guys.
You guys are lucky we're not taking part.
Everyone knows machine learning wins every workshop, so all right, everyone just come in the Kahoot.
Okay, so we're expecting like 26 people, 27. Let's see.
All right, we got FK in the.
It's on, guys. Come on, make us proud.
Come on. Who's I? What are these names? MDE, MK.
Someone rep your own team.
Nah, Sharish, they're not gonna rep their own team in it because they know. Make you proud. Hey, you got Sam for excellence.
Uncle Roger. Interesting. Make you proud. I love this person.
All right. How many do we have so far? We got 19. How many people we got? Oh, sugar, you guys can see my screen. My bad.
Yeah.
We need more people. At least 10 people.
Yeah.
Actually, no, because we're not taking part anymore.
Yeah,
How many do we have right now? We got 32.
Yeah, there's more people.
Come in, guys. Come in. You don't want to miss this out, guys. We've got amazing prizes.
Exactly.
People are sleeping.
Quick dub. Love to see it. Come on, guys. All right. Hey, you got Chris. My guy.
I think.
How many people? 24. We need 3 more, guys. 3 more.
Guys, come on. Come in. He was. Oh.
I don't think anyone's joining. Let's just start.
Is that it? Yeah. Are we starting, guys? Yeah. Are you guys ready?
Yes.
All right. Let's go. I'm starting now. Ooh, machine learning. All right. First question. What is machine learning? Is it
This one's
an algorithm that performs a specific task by studying patterns, a machine humans can learn from, an algorithm that performs a specific task by a set of rules, or none of the above?
Just one choice. Just one.
Yeah, it's only one choice. Yeah.
For all of them, just one.
Oh, there's a bug on my wall. Hey, nice.
Hey, I'm actually proud of you guys. Wow, that's
really
good.
good.
That's nice. Yeah, it's not. We don't give them a set of rules.
Can we see the rankings now, or does it leave?
Oh, it shows it here.
Oh.
Okay. Yeah, Chris is coming up. I see that. All right, let's go. What is the advantage for using machine learning? It's not don't trust the machine. Obviously, don't never trust the machine. Besides large amount of data, better creative output, or trusting the machine means you can focus more on strategy. Oh. This is a bit of a hard one. Ooh, green.
That's interesting.
That's interesting.
I mean, green one is pretty close. The green option is pretty close, guys.
No,
So I'm still proud of you.
exactly. It's better for Chris. Okay.
Very well.
She looks all right. Chris is coming second. Okay, wow. MK still.
Ooh.
Please go first.
All right. Unsupervised learning includes, if you guys were paying attention to my colleague, Christopher, you guys will get this right.
Let's see.
Yo, this song is hard, isn't it?
Exactly.
Ooh.
Oh.
It's clustering. A classification regression that's not part of unsupervised
This is
learning.
Oh, I want to see the rankings now.
MK, are you sure MK isn't in our team?
No.
No.
All right, let's go. Which approach would you use to predict house prices based on location? We have this. Rule-based machine learning, machine. Ooh, this is a tricky one.
Don't get put off by the spelling. I know some people.
All right, nice.
Oh, 2 people got caught out.
But two people fell for it.
Oh, I feel bad for the people who chose yellow.
The spelling, guys. Come on.
Oh, you're on fire, haha.
Oh, MK.
Oh, wow.
That's good.
All right, cool. Machine learning applications are too complex to run in the cloud. True or false? I see answers rolling in quick. I can feel the
Going
confidence.
back to the cloud workshop.
Yes, of course. You can run machine learning applications in the cloud.
Exactly.
Oh,
Collab is on the cloud, basically.
thank you, cloud.
Oh, no way.
Oh,
He's out of it.
binary perceptrons require the input values are binary. This is a very technical question.
Let's see.
Right.
Oh,
I knew this one would catch people.
Explain it.
that's okay.
Anyways, the input values are not. Anyways, let's go next. They're not binary. All right.
Oh, MK is back to first.
What type of machine learning is used to predict the strength of a password? Oh. Christine, this was your one, isn't it? It's gonna throw off a lot of people.
Come on, make us pro, guys.
Come on. Take your time, really think about it. Oh, it's 38 seconds. Oh shit. Oh my bad. Sorry. Apologies. How many people answered?
Might just skip it. That's a long time.
Just skip it. Yeah, 24. Look.
That's a long time.
Yeah.
Oh.
Not bad.
Nah.
Oh.
For sequence prediction. Nah. One of the examples was computation regression. Oof, okay. MK still there.
Okay, yeah. We lost Chris. Oh.
Which of these describe the best way of increasing the accuracy of an ML model? Let's see.
This one should be this
The
one.
best one. Most of them are good, but
Yeah,
the
they're
best
good,
one.
What's the best way?
Let's see, guys.
Come on, guys. You guys can get this one
This
right.
one's difficult as well.
That's it. This bug is always running up the wall, man. It's a bit. Oh yeah.
Oh, you're quite generous with the time, Ryan.
Ooh, that's very even here. Yeah, many times. That's good.
This one was difficult though.
But the best way is to give it new data to learn from. Yeah, let's go next. Okay, MK's still there. Okay, it's looking a bit.
It's far ahead, actually.
Yes.
Oh.
When training a neural network, which ratio of training data to testing data is the most suitable to use? I don't know if you guys can see the picture. It's a bit.
But it's not very important.
Yeah, the picture's not really new.
Yeah, the picture's not really. Yeah, it's not that important.
If you listen to my part, you would definitely know this.
Which ratio of training data to testing data is the most suitable? All right, nice. You guys
Oh,
70, 30.
it's
Oh,
close. It's close.
20.
training was 80%. Testing was 20. Nice, nice. All right. So what rank is this tensor? This was my part.
This is the
Let's see.
Let's see what everyone's gonna get. I think I want to get this right.
I don't think so.
Yeah, no, don't get it right.
Very optimistic.
People are gonna be
Yes, come on. Let's go.
Oh, good, good.
That's good. That's good. Okay, wait, hold on. Is that it?
No, one more.
Yeah.
There's one more.
There's
Oh yeah,
one
11, 11. Okay, what is
Wow.
the third place prize?
Oh,
Alright, though, Kahoot Premium is looking very promising.
Pedro, you gotta help yourself. Man.
Of course you do, Pedro. Of course
Giving
you
you guys
do.
Let's see. Yes, come on, everyone got it right. Yes, lovely stuff.
Well done, man.
Good.
Okay.
You guys paid attention. I love it.
Oh, it just shows.
Oh.
Oh,
All right. NK.
So who are these people, guys?
11,
Show yourself.
11, and I. Yeah, I don't know who these people are, but write in the chat below or send us a message.
Oh, well done.
But yeah, congratulations, guys.
Oh, well done,
congratulations,
guys.
guys.
Yeah, well done.
Congrats.
Guys,
Drop your email, I think, Melissa, and they can contact you.
make sure you guys send proof as well.
Yeah, make sure you take a screenshot or
Take a
something.
screenshot of this.
Yeah. Okay.
Well done.
Mona, I'm not sure how to get in contact with you. I know Pedro and Ipti.
Melissa, drop your email into the chat and they'll contact
Yeah, so just in case I don't say anything the next couple of days, this is my email. And just remind me, I own your prize.
Systems third. Pedro, of course. Of course, it's Pedro.
No, Pedro was second.
No, Pedro is second, yes.
Yeah.
Who's first?
First was
It was MK.
yeah.
Yeah.
Hey.
Yeah.
Well done.
Well done, everyone.
Okay, well done, everyone. Wow, I liked it. It was a
You did really well. To be
nice competition. So do you guys have any questions so far about anything from like the start or maybe about the coding part?
Someone's asking whether
This is the last workshop, unfortunately.
We could try, I don't know.
yeah, this is the last workshop.
This is the last one.
It's getting depressing, but it's reality. I hope you guys enjoyed it, and we're still here to answer your questions. So please don't hesitate to do so.
Thank you, guys.
Thanks, guys.
Yeah, thank you.
Thank you guys, and
Thank
have
you.
a lovely evening.
Lovely evening, guys. Yeah.
I think the core team has to stay behind for Magis.
Yeah.
Yes.
Yeah.
Remember that, guys. I think a lot of people left.
Yeah, so is that the end of it?
Yeah, that's the end.
All right, that's perfect. Thank you, guys. That was really informative. I really like the energy you brought, especially Rayan. I mean, you're like all bouncy and stuff, but that's really cool. That's perfect. You can turn your cameras off, mics off, everything. I'll take over from now.
All right.
Thank you.
Thank you, movies.